Welcome to Algebra 1, Chapter 8, Section 1, Adding and Subtracting Polynomials. Our review is the difference between expression and equation. Remember, an expression is a statement, where an equation is proving two things are equal, so there will be an equal sign. Number 1 does not have an equal sign, it's an, you got it, expression. Problem number 2 does have an equal sign, so it's an equation. Number 3 does not have an equal sign, so it's an expression. Problem number 4 does have an equal sign, so it's an equation. Expressions with only numbers are always like terms. Well, if there's only numbers, there's no variables, so they are alike. An expression can have an equal sign. False. Never has an equal sign. Equations can be true, false, or open. True. Our vocabulary is the prefix poly. Poly means many or several. It is used to make compound words such as polygon or polynomial. Pause this video and fill out the 3 blanks, and then restart the video and see how you did. A monomial or a sum of monomials is called a polynomial. A polygraph test measures many physical reactions of a person who is being questioned in order to determine whether they are telling the truth. And a triangle is one example of a polygon. The degree of a monomial is the sum of the exponents of its variables. For example, in the first one, there's one variable and it has an exponent of 1, so it has a degree of 1. In the second example, we have 2 variables and their exponents are 2 and 3. 2 plus 3 makes 5. In this example, the negative 4 is a number. There are no variables, so that degree is 0. The number 0 has no variables, so again that degree is 0. Here we have the variable x, y, and z. Each one has an exponent of 1. So 1 plus 1 plus 1 makes a degree of 3. Here's one for you to try. Take a moment, pause this video, work through as far as you can, then restart the video. 8xy. Well, for 8xy, the 8 has a degree of 0. The x has a degree of 1, and the y has a degree of 1. So 1 plus 1 is 2. So the monomial has a degree of 2. Looking at negative 7, y to the 4th, z, we see that negative 7 has a degree of 0. Y to the 4th has a degree of 4. And z has a degree of 1. 0 plus 4 plus 1 is 5. So 5 is the degree of that monomial. Looking at number 11, 11 has a degree of 0. Since there are no variables, the degree of this is 0. When adding and subtracting polynomials, we combine like terms. Like terms are those that have the same variable raised to the same degree. Let's determine what the like terms are. We have negative 9a squared. Do we have any other terms here that have an a squared as its variable in degree? 4a squared. There's one other one. Do you see it? 1a squared. 4a to the 4th. Do you see the term that is like 4a to the 4th? 9a to the 4th. And there's one other set we can look at. 35a squared b. 3a squared b. Those are our like terms. So we're going to circle the like terms. So negative 6x to the 4th is like positive 11x to the 4th. And the coefficients is the negative 6 and the 11. So one way to think about simplifying this is using the distributive property. Each of these terms have an x to the 4th. So we're going to take that out and put that on the outside. And on the inside, we're going to have a negative 6 and a positive 11. Well, if you owe 6 and you have 11, you're going to have 5. So your answer is 5x to the 4th. On the second problem, you have a 2x squared y to the 4th and a minus 7 or negative 7x squared y to the 4th. Let's simplify that. Notice that the 2, I know it didn't line up quite right, but the 2 and the 7, -7, are your coefficients. In both cases, we have this x squared y to the 4th. So we're going to put that on the outside. So we have 2 plus a -7. 2 plus a -7 is 2 minus 7, which is a -5. Now, we have some names that we base on their degree and the number of monomials it contains. So if it has a degree of 0, it's called a constant. A degree of 1, it's linear. 2, it's quadratic. 3, it's cubic. And 4 is 4th degree. That's one of the adjectives we use. You also base on the number of terms. If it has one term, it's monomial. 2, think 2. 2 wheels is a bicycle, binomial. 3 wheels is a tricycle, trinomial. In this case here, we have a 6. That's a constant, and it's a constant monomial. Well, usually we just refer to as a constant. Here we have 2 terms, but our degree is 1. So it is a linear binomial. Here our highest degree is 2. So this polynomial has a degree of 2 because that's our highest degree. That means it's a quadratic. And then it has 1, 2, 3 terms. So it's a quadratic trinomial. Here we have a degree of 3. So that makes it a cubic, but there's only one term. So it's a cubic monomial. Here our highest degree is 4, so this polynomial has a degree of 4. It's a 4th degree, and we have 1, 2, 3 terms, so it's a 4th degree trinomial. As we introduced in the last slide, a polynomial is a monomial or binomial or trinomial or anything that's a monomial or larger that shows the sum of difference of terms. Now each term has a degree, and the degree is the sum of the exponents of the variables. Degree of 4, degree of 2, degree of 1, degree of 0. The degree of the whole polynomial is the same as the degree of the monomial with the greatest exponent. So of these, this 4 is the greatest exponent. So the degree of this polynomial is 4. The standard form of a polynomial is where the monomial terms, each term decreases from left to right, and you must combine the like terms. So as you see in this one, your highest exponent is minus 2x squared plus 3x squared. Well, minus 2x squared plus 3x squared is 1x squared. And then you have a plus x and a plus 4x. Well, that would be plus 5x. And then you have your constant plus 5. So now this is in standard form. Your highest degree is first, and it goes down from there, ending with a constant. I've included this chart on names of polynomials. You might want to cut this out and put it in your agenda as a guide for test taking. You have the chart on the left, which deals with the degree and the name based on the degree. And then the chart on the right is the name of polynomials based on the number of terms in each one. Again, feel free to cut this out and glue it in your agenda. We're going to write 2x minus 3 plus 8x squared in standard form. And we'll name it based on its degree and the number of terms. The greatest degree term is 8x squared. Then we have a positive 2x, and then we have a minus 3 as our constant. So to write this in standard form, 8x squared plus 2x minus 3. Because the highest exponent is 2, this is a degree of 2. Something that has a degree of 2 is a quadratic. It has 1, 2, 3 terms. 3 terms means it's a trinomial. So this is a quadratic trinomial. Whether you're adding or subtracting polynomials, it's simply grouping like terms together and combining them. Let's see how this is done. So we have 9y minus 7x plus 15a. This makes a negative 3y. This plus a positive 8x plus a negative 8a. Now we're going to combine like terms. So we have a 9y and we have a minus 3y. Well, that would be 6y. We have a minus 7x. Notice the sign is going with it, plus 8x. So it's plus 1x or plus x. Then we have plus of 15a minus 8a. So it's a positive 7a. Now it's traditionally more accepted to put these, if not in degree order, which is what standard polynomial is degree order, then it's alphabetical. So 7a plus 1x, or just x, plus 6y. A couple things to note. The sign always follows the term that comes after it. So as we move forward, don't forget that. And let's add this trinomial to this binomial. So we have 3a squared plus 3ab minus b squared plus a positive 4ab plus a positive 6b squared. Now our like terms is this 3a squared. I don't have any other 3a squared, so it's going to come straight down. Now I'm going to look at positive 3ab plus 4ab. Those are like terms. They both have an a and a b variable. That'd be plus 7ab. Then I have a minus b squared plus 6b squared. Well, if I owe 1 and I have 6, I'm going to have 5b squared. So that's simply my solution. Do you see how straightforward that was? Do you see how straightforward that was? If not, bring questions to class. In this example, I have two trinomials, and the second one is being subtracted from the first. We're going to do this process a little differently. In the previous example, I underlined like terms and combined them. In this one, we're going to do a lineup, and some people find this a little more helpful. Either method works. So looking at just the first trinomial, we see we have a minus 4m cubed plus, now here I have an m squared, but there's no m squared in this trinomial, so I'm going to put a 0 there. Minus 1m plus 9. I'm going to take that and I'm going to rewrite that right down here. So we have it in both places. Now for the second trinomial, I'm going to worry about just what's inside the trinomial. Now here I do not have a 4m cubed, so I'm going to put a 0 here for the 4m cubed. It's kind of like a placeholder. Plus 4m squared plus 1 minus 12. Now for the second line, I need to apply this negative to every term. So negative times 0m cubed is minus 0m cubed. I know that can't really exist, but it shows you how this works. Minus times a positive 4m squared is a negative 4m squared. Negative times a positive 1m is a negative 1m. Negative times a negative 12 is a positive 12. Now I can go ahead and combine these. So going down, I have minus 4m cubed minus 0m cubed. You get minus 4m cubed. I have 0m squared minus 4m squared, and I get a negative 4m squared. Minus 1m is minus 2m. 9 plus 12 is 21. So my simplified version is minus 4m cubed minus 4m squared minus 2m plus 21. If you have questions on this, make sure you bring them to class. Let's go ahead and subtract these two trinomials. This one, I'm going to do the original way I showed you, where we're going to write down 9y minus 7x plus 15a. Negative times negative is positive 3y. Negative times positive is negative 8x. Negative times negative is positive 8a. Now let's look at like terms. 9y plus 3y. 12y. Minus 7x minus 8x minus 15x. Plus 15a plus 8a plus 23a. Put these in order. 23a minus 15x plus 12y. Since each of these terms has a degree of 1, we're going to put them in alphabetical order. Well, you've made it to the end of yet another video. Do your lesson check and bring any questions you have to class tomorrow.